Hi everyone, hope so you are doing fine. So today again I am going to solve the daily challenge problems of LeetCode, and yeah, if I able to solve it early, then I will try to solve the another problems like previous like a part will try to solve the past contest. So yeah, let's start without wasting any further time. So yeah, so the today problem is find a safe walk through a grid. So in this problem, we have a given a grid of m cross n, like a binary matrix grid or an integer health. And you start from upper left, like we can start from 0 0, and we have to reach the right lower corner. So like m minus 1 and n minus 1. So we can move up, down, left, and right from a cell to another adjacent cell as long as your health remain like if the health is positive, then we can move. So like if we are at cell ij with grid value I are considered unsafe and reduce our health by 1. So like if the value of grid cell is 1, then it means that we need health of 1 to move from that cell to another cell. Yeah. So return true if you can reach the final cell with the health value of 1 or more, and false otherwise. So we have to return to if we can reach this m minus 1 and n minus 1 cell. If not possible, then we have to return false. So yeah, this problem is like in this m and n are quite less like a 50. So I think like this problem is quite similar to the problem which we solved yesterday. So yeah, so let's see how we can solve this problem. So yeah, we like in this we have given something like a matrix like this. So we have something like we have a variable name as health, like we have something like health equal to let's assume it's a tree, and we have something like a grid with the random ones, and else all values are 0. So yeah, so we have to return the minimum like whether it is possible to reach that is like n minus 1 comma m minus 1 cell from 0 0. So first approach is like the yesterday problem, but we can simply find all the path, like we'll try to generate all the path. So yeah, I think first approach is that we can generate all the path. So but I think instead of doing that, we can do something optimize. So like in this case the h is 3. So what we can do, we can simply, can we do think something like a binary search yeah, we do in a yesterday problem. Like if we have h equal to 3, can we check is it possible for 3 to do? I think not, it is not possible. So what we can do, we can simply let's say this is our matrix. Now what we can do, so like what is the this dp let's name it as a dp. This will store like what is the minimum with maximum health we can reach at this cell. What is the maximum health? So in this to reach this value, so maximum health can be a 2 because the health is 3. So to reach this, the health will decrease by 1, so it is 2. So again from here we can move to this node, so health will remain same 2. Then let's say this is 1. and also this is 1 also. So to reach this, the health will going to become 1, and same for this. From here, let's say from here we can reach to here, the health will become 0. Now from 0, let's say we assume, we move to this node, this cell, and from this cell to this. Now the to reach this, we can't move further from here to here, because the we need 1 to reach like this health, so we can't reach this. So let's remove this thing because we can't read this reach this position. So from 1, like we can again move to this 1, and then again it becomes 0, like. But you can see, like, from 2 we can also move here to with 2 value also, from here 2, from here 2, 2, and so here the value is 1, so it remain 1, again for here 1, and again now here we reach with the 0 health. So yeah, so we can reach with the 0 health, here the health becomes 0, so it means that we reach n cross m. So by doing this we can say yeah, it is possible. So let's see, like, whether the health must be greater than self value of 1 or more. Like, so yeah, in this case it is not we can't reach, like, we can say we can't reach because this is the best we can reach, but the value must be greater than equal to 1. So what I am trying to do, like, we are simply going to start with the first value, and then from first we are going to iterate to its all the, like, all its 4 direction, and then after that we will trying to update, like, whether like what is the maximum value we can reach here. Like from here we reach here 2, and we also reach here with the 2. Then again we add this into our priority queue. From then we will pop out the maximum one, like maximum one is the 2. So again from 2, let's say we move to 1 here, and again move to 2 here. Now again 2 will be the like 2 will pop out because we are going to take a max priority queue. So by doing this way, I think we can solve this problem. So yeah, so let's write the code for this. So we have something, we have grid. So yeah, let's write the code in our editor only. So I am just taking the this this grid input. So yeah, let's take this input v of I comma j, and then also we have something like a health, and take this input. Yeah, so now we have to create the object for this class solution, and then we call s dot find savewalk, and we can pass v comma health, and it is going to return, like, you can simply mark it as answer. Like if answer is true, then see you out. Yes, we can say print, we can simply print uh, yes, else see you out, no. So yeah, so we need a max priority queue, like it is going to be pair of int. So yeah, it is going to be max. So we need using pi I equal to pair of int comma pair pair of int comma int. So we are going to add pq dot push like health minus v of 0 comma 0. Let's say int n equal to v dot size, and int m equal to v of 0 dot size. So like n cross m. So we need to check like while not of pq dot empty. So we can simply check like if the so we can simply check if health health minus like v of 0 comma 0 is less than equal to 0, then we can simply return false because it is not possible. So else we can try, we are going to take the pq dot top, yeah, we are going to do pq dot pop, and also we need a like a 2D vector to do maintain that value. And then we are going to like it's going to be n plus 1 cross m plus 1, and initially it is going to be like we have to take them maximum value, so it is going to be take a int mean as a minimum initial value, and dp of 0 comma 0 is going to be a health, oh, sorry, yeah, health minus v of 0 comma v of 0, yeah, this is going to be this value. And so now we are popping it. Now the like int value is going to be a it dot first, and like a is going to be a it dot second dot first, and b is going to it dot second. So we now move in all the four direction like left, right, up and down. Yeah, so the simple way to do this thing is like we are going to take a two array of four size like 0 0 1 and minus 1 or minus 1, and similarly array 2 of size 4 with value 1 comma minus 1 comma 0 comma 0. And now x is going to be a plus array 1 of k, and int y is going to be a b plus array 2 of k. So we check if the x is greater than equal to 0 and y is greater than equal to 0 and x less than n, and also y should be less than m. And also so we check like in new value will become, so yeah, if it is true, then we will check like int new value is going to be a, or we can say like, and uh, value minus v of x comma y must be greater than dp of x comma y. If it is true, then we can update like a dp of x comma y is going to be a value minus v of x comma y, and we have to push it in our q dot push. We can say we have to push like what have to push we have to firstly push the value like a dp of x comma y, then we have to again push like x comma y. So yeah, we also have to push 0 0 here. So I think so this is, so yeah, so at last we are going to return like false, and we can simply check like here if a equal to n minus 1 and b equal to like b equals to m minus 1, then we have to simply return true. So yeah, so let's take the example from here like uh, yeah, so let's copy paste this thing. And so example is like 4 cross 4 0 1 0 0 0, sorry, no, the like the constraints are like n and m value is not same, so n is 3 and m is 4. and health is 1. So yeah, so but in like we are only input taking the input of n only, so we have to take m also. So yeah, let's see. So yeah, it is giving correct for this on this test case. So let's try to submit this out and see if it is working or not. Oh yeah, output is true, but in actual the answer should be a false. So yeah, let's see why for this test case it is giving answer as a. So yeah, we missed one thing like and also the val minus, we can say v of x comma y must be greater than 0. So yeah, I think now it should work because value can't be 0 or less than like we can say 0 or be a negative value. So we are checking that thing. So yeah, let's try to submit this out and see if it is working or not. So yeah, so you can see like so today in one go we was able to like I was able to solve the problem. So let's now uh, try to understand what I have done in this problem. So what I have done is so instead of doing this let's simply take the screenshot of this thing. So yeah, so what we are doing like we have something we have a matrix of n cross m, and we have something like health is given. Why it is not working? Like we have something like health, and health has, let's assume, 3. So we are trying to like firstly like this is the thing to iterate in a 4 direction like by 0 1, like if we make x as 0, like add x to 0 and y as 1. So by doing this we are going to move like x remains same and y become, so it is a right direction again. So for 0 minus 1 it is going to be left, and 1 0 it is going to be a down, and for like minus 1 and minus 1 and 0 it is going to be up. So yeah, this is for that thing, and I am defining a pair of pair. So in priority queue we are storing the what is like a value and a pair like a cell value I comma j. So yeah, so firstly initially I am taking like if the value present here is 1 and also the at like health is 1, so in that case like it is become 0 0, or if the health is already a 0. So in that case it is not possible. So in that case I am simply returning the false, else I am making a max priority queue, and then I am putting the like health minus v of 0, like the current the value here is, if it is 0, then like we are pushing health, or else it will be h minus 1, we can say, because the as the matrix can only have a 0 and 1. So yeah, that's it. So again, so after that I am taking like n comma m, like size of this grid, and after that I am creating a dp array of n cross m size, and initializing it with the int min value, because we have to check for maximum, like we have to maintain maximum. So initially I'm defining it with int min, and but for dp of 0 comma 0 I am defining it with the health minus v of 0 comma 0. Yeah. So now I am doing looping doing a while loop. So what I am doing in this, firstly I am pop outing the like a first element, let's say here the value is 3. So I am pop out this value, and then move to try to move in its left, right, up and down direction. So yeah, like it's 4 direction. And before that I am checking like if the a is equal to n minus 1 and b equal to m minus 1. So in that case I am simply returning it is possible, so I am returning true, else I am going to traverse in all its 4 direction, and then x become like a plus like this 4 direction, left, right, up and down, these are that thing. So x y y will store that value, new value, and I am checking like if it is in a grid, like for this, like if we move in a left direction, we will go out of the grid. So yeah, so I am checking that condition, and after that I am checking like if the value minus v of x comma y must be greater than dp of xy. So like if I am already reached this index with the value 4, and from like let's say value here is also 4, then I am here is the 4. So now there is some path from here I am reaching with a value of 2. So is there is a fun of taking 2, because like if we can reach here with the maximum value, then we have to it is better for us to reach here with the maximum value, because if in a future path there are one like one this is going to be decreased. So yeah, so we can choose maximum number of one after this path. So that's why I am taking this, and again after that I am checking like val minus v of x my must be greater than 0, like if this value becomes 0, like let's say this is 1 1 1 and 1. So after reaching here it value becomes 0, so there is no fun of taking this cell, because we can't reach here. So yeah, after that if it is possible, then I am pushing in a queue and updating the value in a dp, like so that I can't again like do like if I am again reaching here with a value less than or equal to that, so I am not taking that path. So yeah, it's a quite simple problem. So now let's again let's solve try to solve another contest of the contest of the lead code. So here is that thing. So yeah, let's see the contest. Contest like which I think I have solved one. Let's see if I have solved this. So yeah, I think I have not solved this contest. So yeah, let's start this contest. So let's start the virtual contest for this. Digit frequency score. So the for the first problem is digit frequency score. In this we are given an integer n, and the score of n is defined as the sum of d into frequency of d over all distinct d, where frequency of d denotes the number of time the digit d appear in n. Return the integer denoting the score of n. So like n is 1 2 2, digit 1 appear 1 times, the contribution is 1 cross 1. digits to appear two times, the contribution is 4. So answer is 5. The score of n is defined as the sum of d into frequency of d. Sum of d into frequency of d over all distinct d. So yeah, so what we have to do, we have to simply check like count the number. Like in this example, 1 to 2, 1 is present one time and 2 is present two time. So yeah, you can see 1 into 1 is 1 and 2 into 2 is 4. So so let's say for 101 it is 2 because 0 is present one time and 1 is present time. 0 into 1 is going to be 0 and 1 into 2 is going to be a 2. So yeah, so dz can be up to like from 0 to n. So we can simply make a like a count like a dp of uh, we can say 10 comma 0. Initially the all value are 0. So while like n is greater than equal to 0, we are taking the last value like int value is going to be n modulo 10 and val equal to val divided by uh sorry val not val n equal to and divided by 10, and we are going to increase the value of dp of val plus equal to 1. So then we can simply iterate our this int I equal to 0, I less than equal to 9 and I plus plus. We can the answer equal to answer plus like answer plus equal to uh I into v of like we can say dp of I. So yeah, this is our going to be our answer, and initially our answer is going to be a 0. So let's see. So we have to traverse like until the n value is greater than 0. So for first the value is 5, answer is 5, and for second the answer is 2. So let's try to submit this thing. Yeah, so it is working. So let's try the second problem. So maximum number of items for sale 1. So in this problem we are given a 2D integer array items where items of I equal to factor of I comma price of. So so you so in this problem we are given a 2D integer array item of I equal to factor of I comma price I of I represent the ith item. So you are also given a integer budget. There are unlimited copies of each item available for purchase. You may buy any number of copies of any item such that the total cost of the purchase copy is at most budget. So yeah, so we can purchase the like a different type of items, and it must be the total price of that items must be in our budget. After buying items you may receive free copies according to the following rules. For each items I that you bought bought at least one copy of, you receive one free copy for every item j, such that I and j uh, I is not equal to j, and factor of I divide factor of j. Buying multiple copies of same items I does not give additional free copies through item I. The same item j can be received multiple times for free if it is received from purchase of different item types. And we have to return the maximum total number of item copies you can obtain, including both purchased copies and free copies while spending at most by at most budget. So like the item's length is like 1,000 and a factor of I and price is less than equal to 1,500. So like so whenever we buy ith item, at least one copy of if for each item I that you buy at least one copy, you receive one free copy of every item j, such that I and j is not equal to I and j are not equal, but their factor is same. So like what we can do, we can simply let's take some value, but yeah, the cost also matters, the price also matters. So one thing is firstly we will try, let's say we are going to buy one buy this six tool, like first item. So in this case the price is 2 and the factor I is 6. So in that case, like if we buy 6 2, we can get free for 2 6 for free, we can say. uh, yeah, because 2 modulo 6 is going to be a 0. So we can, if we buy one item from here, we get this one for free. And we can buy like 4 items, we can buy 4 items and get this for 2 6 for free. So this is the one case. So like can this it is always optimal to take the minimum value? No, because there may be possibility uh for this factor of I value, there is a no other possible j exists where the factor of I factor of j divides factor of I. So we also have to think of that case. So what we can do, so so one thing we can do is so we have something like a value of factor comma price. We have something like factor comma price. So we have something like a factor comma price. So if the, so what we can do, we can simply calculate we have something like from of this like a 2D array of size 1 0 to n. So what we can do, we can for every value, let's say we have something like 2 comma 6, 2 comma 2, 4 comma 2. So for every for every I, we can calculate what are the different j which can divide whose factor can divide ith factor. So let's say here the factor is 6. So you can say the factor is 6, here the this two factor can easily divide. So for this the value is going to be 1. So for 2 the value is going to be 0, because nobody no other j index factor can divide it. So for 4, this 2 can divide. So for this the factor is 1. So after doing that, we know what gains we can get from this. So after that, what we can do, we can simply try to generate by like so for that, then we have different options, like whether we can choose this or not. So if the values, like if value is 6 here, so we have option to whether we can take this or not take this. If we are going to take this, then our our number of number of items we can buy is equal to be like this value, like we can say like this is a free array, like free of I plus 1, and we our what we can say, our budget will be decreased by its this value, this price value. Budget is going to be decreased by minus price, like, yeah. So by doing this, like now we have chosen we have choose this one time, so we have multiple times to choose this, like we can choose this multiple times, like either one time, two time, two three times, four times, or we can say, yeah. So we have like something like, in worst case, like if the values and like if value is going to be 1, this value is going to be a one, price is going to 1, as the budget value can be 1500. So yeah, let's see constraint. I think it's 1500, budget can be up to 1500, yeah. So it's going to be a 1500. So yeah, so we have that much option for this thing. So it's going to be a like something like we have some index which can be moved from I to n, and then we have something like a budget. So we have something like index comma budget. So yeah, so I think we can do we like it can become like something like choose not choose DP. So we have option like we can choose this or we can skip this. If we have choose this, we have further we have one option, like can we again want to choose this thing. So but in that case, I think the time complexity will going to be NQ, because we have to traverse for every every different possible ways, like because we have around 1500 option for everything, like whether we can choose this or not. So yeah, let's try to write the code for this thing. So we have something like firstly we need to firstly we need the price array. For that we have something like we need to iterate our whole array, and let's say n equal to items that size I less than n I plus plus, and then again we loop from and j equal to 0, j less than yeah, j less than n, j plus plus, and if I equal to j, then we have to continue, else we can make free of like if dp of we can say dp of I comma 1 sorry 0, because the first value is the factor, modulo dp of j comma 0 is going to be a 0, then it means that free of I plus equal to 1. So that much profit we can free we can get for this that I. So yeah, so after doing that we can simply run our DP recursive code, and then we will memorize that thing. So we have something like items, like we can say items, we are naming it as a V, and we have something like index, and we have something like budget. So now we have two option, like if the V of index comma one value is less than or equal to budget, then we can simply we have two option, whether we can choose like answer one is going to be, we are choosing that thing. So if we are choosing that thing, we will get 1 plus free of I plus function of, now we are, if we are choosing this, we remain at same index, and our budget will decrease by v of idx comma 1. So yeah, and another thing is like we are not choosing this. So if we are not choosing this, we are going to index plus 1, and our budget will remain as budget. And as we have no option, we have to skip that thing only. So it will remain index plus 1 comma we can say budget. So instead of writing this thing again and again, we can simply move this thing out of the loop, so that it will check for everything, like every case. So initially answer one going to be a 0, and answer two, like here the answer two is going to be, and we have to return the max of all the cases, no? I think yeah. So we have to return the max of both cases, whether we are choosing this or not choosing this. So yeah, I think that's it for this recursion thing. And now we have to simply we have also passed a free array here also, vector int free. Yeah, we also need to pass this free here also. Return function of v comma we have index comma budget comma free, index comma budget comma free. So let's try to run this. So we are getting, so it is going to be index. Yeah, let's try now. So yeah, we have to also pass free thing here also. Two semicolon. Yeah, dpf comma, sorry, it is going to be a v, not dp. And we also have to change these items to a v. I think now it should work. Oh shit, I have submitted this thing. And so yeah, we I forget to declare the free array of size, and comma free is going to be, initially the value is going to be a 0. Why I'm getting, so yeah, so one thing I missed is like if the index is greater than equal to n, then we have to break we have to return 0. because we have reached the end of the our array items array. So yeah, int n is going to be a v dot size. So output is 12. How is it even possible? Auto it comma, what is the free array we are getting? So we are getting free as 200. So yeah, so we are subtracting the value of v of idx comma 1. Yeah, it's correct. And we are doing 1 plus free of index 1 plus 2 equal to 3 for everything. I don't think for 1 I think the value should be a 1 only. How it is 2? Because mm, 6 modulo 3 yeah, 3 is also going to be a 0. So you can buy 2 copies of item 0 and 1 copy of item 2 for a total of 2 into 2 plus 4, which is not greater than it. Like you can buy 2 copies of items 0 and 1 copy of item 2. Buying 2 gives 1 free copy of item 0. So buying multiple copies of same items that give additional free copies through them. So for each item I that you bought at least 1 copy of, you receive 1 free copy of every item j such that j is not equal to I and a factor of I divides factor of j. Factor of I. Factor of I divide factor of j, not factor of j divide factor of I. So it is going to be a reverse thing. So yeah, I think it should work. But for this again we are getting wrong answer. So let's see, like for this you can buy 1 copy of item 0. 2 can do this like 1, 2, 3, like 3. We can got 3 copies. Buying item 0 gives 1 free copy of item 2, 3, 4. Yeah, we get 4 items. Then buying item 1 gives uh 3, 4, 5. So yeah, 4. Mm, price is 4 comma 4 8, so we get 3 comma 3 6 only copies. We get 3 copies for 4 price, and for this 4 price we get 2 copies. 2 into 4 like not, we can say yeah, 4. Buying 1 items of 1 gives free 1 copy of 3 and 4. 3 and 4, like 2 items and 2 from here, 2 2 comma 2 4 and 5 6 7 8. Like how? We can get 4 from here and 3 from here. 4 plus 3 7 and 7 plus 3. Like we are getting four copies if we buy one items, one copy of that, zero if we buy zero item we get four copies, like one this and three other as a free. Yeah, then we want this two, like one copy of this two, then we get 2 plus 1 3. It is going to be a 3 comma 2. Yeah, 4 plus 3 7, 7 plus again we can buy this 7 plus 3, it is going to be a 10. Then how it is 16? The unlimited copy of each item available. You must buy any number of copies of any items such that total cost. Like, can we buy? Yeah, there is no constraint. So yeah, so in this we can always buy like this 4 comma 2. Like it is going to be 8. Then how it is 4 comma 16? How it becomes 16? We are going to buy 1 plus free of index for v of v of idx comma 1. It is going to be a 1 plus so let's print here the index comma budget yeah index comma budget comma answer 1 answer 2. Index 2 0 1 2 and a budget of 6. So yeah, I think like if we can buy 8 items of this thing, then again we get this profit. Like 8 into 2, it is going to be 16. So there are unlimited represent the ith item. You are given an integer budget. There are unlimited copies of each item available for purchase. You may buy any number of copies, any item such that the total cost of purchase copies is at most budget. After buying items, you may receive free copies according to value. For each item I that you bought at least one copy of, you receive one free copy of every j items such that I is not equal to j and a factor of I divides factor of j. Buying multiple copies of same item does not give additional free copies. Oh, sorry. So like this is going to be give a free copies only first time. So we can say like make a boolean as free possible. Like if free possible, then we are going to take this thing. If free possible, if free possible, then we have take like we get this thing, else we get a zero. And in this case, the free possible become false in case of if we don't like if we won't don't take it. And initially the free here the free possible become true, like it is free possible is true, and initially it is also going to be a true. So yeah, so I think now it should work. Now we are getting 8 and here we are getting 2. So if we get free possible, initially free possible true. So if we are going to be this, then we have something like we can take 1 plus free possible value is true, then we get free of indx does not give additional free copy through item I. Yeah, I think I am doing yeah, but in this case the free possible become false. So if free possible is true, then we get 1 plus free index, and then free possible become false in that case because we are not moving index. In another case free possible become true, and if the v of index comma 1 less than equal to budget, then we get 1 plus. Yeah, I think it should be a should give correct answer. So let's print this thing out. We reach index 3 with budget of 4. Sorry, 2. 3 with budget of 2, or 2 with budget of 4. Yeah, 2 with budget of 4. We get answer as 4. we get one copy, then we have got three copies, like four copies for this thing for 4 rupee. Then we get one copy for two, five, 6, 7, 8. So buying item zeros give one free copy of item 2, 3, 4. So we get total four items. And buying one gives one free copy of item 3 and 4. So we get 3, comma 4 is equal to 7. Yeah, 7. And then we have one copy of 2. We get 8. Yeah, I think we should get free possible 1, then again 0. Index, comma free possible, comma budget. So let's print it out. Like I is index is going to be 0. Free possible is going to be a 1 and budget is 8. So after that budget is going to be 4 and we get what is this thing we get. So we can also log this out. Like we are passing free possible as true. So if the free possible true, then how it is going to be a 0? So I think I need to write a bracket here. Yeah, now it is working. So yeah, let's see. Yeah, so this is working. So let's try to submit this out. So it is going to give us a TLE. So yeah, I know it. So let's memorize this thing. So yeah, for memorization we need something like a DP of index. Like index can be up to 1,000 and budget can be up to 1,500, I can say. And free possible can be of two value. Can be of two value. So yeah, so if TP off, index comma budget comma free is not equal to -1 we have to return this dp of 1001 comma 1500 comma 2 y- dp, oh sorry, dp of index comma budget comma free possible is equal to, so we have to return same thing here also. So yeah, so we have to mark this with a -1 and type dp comma -1 comma size of dp. So yeah, let's try to run this now. It is giving 4 and 10. I think it is correct. And for this, the answer is 56. So let's try to submit this. So yeah, it is going to 1501. So let's try to submit this now. So I think yeah, now it's working. So let's move to the third problem. So maximum number of items from sale to. So I think it is going to be a same. You get at most one free copy of another J. For each order per I, you can receive a free copy of item J from purchase of item I at most once, regardless of how many copies of item I you buy. So in this, like we will always get only one copy for free. So I think it is like it's a greedy problem, like the like it's the same problem as second one, but in second problem what we have something like you can receive multiple copies, like for factor of like where the factor of I divides factor of j, we received all like all the free copies, but in this case we can receive only one copy. So yeah, so what we can we can, I think we can do is like for every for every I we will calculate something like a free array, like free array, like something like free array. This is going to be a free array, and for every like for everything, like we will calculate like for this, like if the value is one, like greater than or equal to one, like let's say for here it is 0, here is 2, here is 0, and here is 0. So for where the every value, like if the value of free is greater than equal to 1, it means that we get one free for sure for this if we buy this. So we will try to buy like, firstly we see like if the minimum price, like if the price of, if the price of item is minimum, like some price of I, like there will be always be a one item whose price is minimum, like minimum price, like item with minimum price, we can check if the item with minimum price has value greater than like if value has 1, like free is 1, so we can buy that item one and we get free for one. And for now other thing we will check, like if the price of anything else is less than like two, like twice the x, like if it is less than 2x, if price is less than 2x, like if the price of it is x, if the someone has price less than 2x and its value of free is greater than equal to 1, it means that like in less than that price we are getting two items. So like if we take two items, or like if we take because we have already got the minimum with one value free get, so we have already have two items in our bag with a budget of like with x value. So now again to buy one item we need x, and to buy two items we need 2x money. So instead of buying this for 2x money, firstly let's see if there is any value whose price is less than 2x and have value one free, we get one free value. So if it is possible then we will try to take that one that all. And if again we have some budget, then we again buy, like we can then buy left x, like if we have something like n x left, then we buy an item more. So yeah, I think it's a pretty easy problem than previous also, I think. So we have we need something like, firstly that we need a v for purchase copy of item I, you can at most get one free copy. Yeah, factor of I divided factor of j. So I think we need this same thing. So let's copy from this thing only. So so yeah, let's now what we have, like we have done this thing. So we can now like we can, I think we can take priority queue also. Like we can simply track the mean value. So yeah, so like int mean cost, like mean cost, and int index. So initially is going to be -1 and mean cost is going to be int max we can say. And we can say the mean cost is going to be mean of mean cost comma dp of I comma 1. And yeah, but we have also to check like something like if the dp of I comma 1 is less than mean cost, we can simply make mean cost as dp of I comma 1. And we also have to update index with I. So yeah, so now we can check like if the, because it's a minimum value, so we can check if the budget is less than mean cost. It means that we cannot buy anything, so we can simply return 0. And else we can say we can buy at least one item. We can say budget is going to be budget minus equal to min cost. Yeah, and our answer is going to become 2, and initially answer is 0. So now what we have to do, like we can simply sort our v like v dot begin comma v dot end according to according to the price thing, or we can say like we can only add the value like for loop int I equal to 0, I less than and I plus plus, and we can see if the index is not equal to I, and also the free of I is greater than equal to 0, then we can simply add it is in our t array, t dot push we can say dp of I comma 1, we are going to add budget. So we have something like t, and we are going to sort this t array, t dot begin comma t dot and after sorting, like we can say if I equal to 0, I less than t dot size I plus plus. So if price of we can say t of I less than 2x, 2 into price min cost, sorry, if it is less than 2 into min cost, then answer plus equal to 2, and also the budget is going to be decreased by t of I, and also we have to check budget must be greater than equal to t of I. Yeah, this thing. And like if after doing this again we get some budget left, we can say like if we have some budget like if budget is greater than equal to min cost, we can say answer plus equal to bud budget divide by min cost, we can say. Yeah, let's see. So oh, yeah, it's going to be a v, not dp here. Why I am take the so like it's a t simple array, not a vector of vector. We can simply add dp of I comma 1 in it, t dot push back. So it's so it's instead of dp it is a v. I have used dp everywhere instead of v. Of syntax error. So it's giving us 7 in both cases. 162435, and our budget is 19. So we can buy something like, so let's print the free and the t array for auto it comma free keyword it for auto it comma t, and we have something like keyword index comma min cost min cost uh, where I make error. So for eh? So yeah, so for one the answer is 2 with the cost of 6. So we can buy something like the budgeted is 19. So we can buy something like 6 for this like if this is true. Oh sorry, I think like answer is going to be 2 only if uh, yeah like we can say we can do this thing only if the free of index is greater than equal to 1, then we can do something like this. Now let's see. Again I am getting 6 here, 6 here. So the cost is going to be a 4 for 1. Mean cost is 1 for index 1. uh so yeah, so firstly we are going to buy in this free we have only 5 comma 6. How 5 comma 6? For 5 we can get any value? Yeah, for 6. Firstly we buy 6 for 1 and 5 11. 6 comma 5 for 6 I am, so it must be greater than 0. So I can buy one item for 6 6 yeah 6 for one item. For in 6 I am getting two item for 6. Then I have left with 10. I say we can say is 13. 13 for 3 we get for 4 14. Yeah, it is correct. And for now for second we have something like for 2 v of j comma modulo I is going to be free of I plus equal to 1. So for 8, so for 2 we have something like 1 2 2. For 1 we have something like 3 4 5. And for 6 we have something like 0. And for 4 we have 0. For 5 we have 1. Again for 5 we have 1. So now it's look something like this. For cost 8 we can get this thing and the minimum is 6. So yeah, so we can get 8 for 2, 2 for 8, 10 for 2, 10 is for which thing? Yeah, sorry, yeah, 8, 8, 2 for 8 and 2 for 10, like total cost of 18. 18, and then 6 has, the 6 has 1. So yeah, so 6 has 3, 6 has 0 value. So we get 18 for 4, 4 for 18, 4 for 18. Now we get 6, 6, 12, and 18, 18 is 36. One purchase copy of item 0 gives one free. Yeah, free item must satisfy I is not equal to j, and factor of I divides factor of j. For each ordered pair ij, you can receive a free copy of item j from purchase of item I at most once, regardless of how many copies of item 1 you buy. So how we are getting 7? Like 2 from 8, 8 is 16, 16 for 3. 1 purchased copy of item 0 gives 1 free copy of item 2. Yeah, this is correct, because yeah, 1 other purchased copy of item 0 free, gives 1 free copy of items 3, because so we can get multiple copies for free for that case also. So we can say we can get that much copies, and we can get free of I is greater than equal to 0, like that thing. Free of IDX, like we can say, uh, we can do something like, because I misunderstood the problem. So like, one purchased copy of item 0 gives one free copy of item, because one factor, sorry, the free item must satisfy I is not equal to j, and the factor of ij divides j. For each order pair ij, you can receive a free copy of item j from purchase item, at most one, regardless of how many copies of like item I you can buy. So like, if we can make different pair, like if I buy firstly like using this pair, two, like 0 and 2, and then again I can buy using 0 comma 3 also. So in that case we are getting free. So So yeah, so to achieve that thing, so we can simply add something like free of I comma free of I also here. So now we are going to decrease this value of t of I comma 1, we can say t of I comma 0 should be, it is also going to be t of I comma 0, it is going to be 0, and t of I comma 1 minus equal to 1. If it is true, then we can do something like that. So yeah, let's see now. So for I think, so let's print here budget. So instead of like if we are going to use while loop, because we have to iterate multiple time this thing now, because we can buy multiple time. So yeah, now it's working. So let's try to submit this out. Again getting wrong answer. Min cost is 10. Hmm. So we have something like 71. So if we get 10 for this thing, so yeah. So in this also we get something like free of I free. and we can say less than or equal to cost of I, and we can say we can also add like, so instead of doing this in the starting, we can also add like if it is equal to mean value, then we have to don't check this condition again and again. So I think now we will get correct answer 47. Yeah, so let's try to submit this out now. I think it will give TLE due to this console. Yeah, let's now submit. Again getting TLE. uh, I don't think I should get a TLE. So yeah, so we can get will get TLE due to this thing, cause in this we are like n is 10 raised to power 5, so we have to do this thing in optimized way. How we can do this thing in optimized way? Like what is the cost, what is the value of factor of I? So yeah, factor of I should be less than equal to 10 raised to power 5. So I think we can do this in optimized way, like by doing pre-computation. So what I am thinking of is like we have range of only range from 1 to 10 raised to power 5. So you can see like for any number 8 can like for, let's say example for we have something like 18. So 18 can give us answer like something like 8 can be divisible by 9, and now 9 can be divisible by like we can say 3. So it means like 18 is also divisible by 3. So something like 3 is not divisible by anyone. So we can stop like that. So yeah, I am thinking of that approach. So let's try it. Let me write firstly code for that, and after that I will explain. So we need this thing. I think we have to comment. We can comment this thing, and we can make a DP of. We can say V of I com 0 plus equal to 1. For loop int I equal to 0, I less than n I plus plus. In fact, int temp equal to factor of like what is a factor? Factor is going to be a v of I comma 0, and while factor is greater than 0. Yeah, like factor equal to factor divide. If factor, like what is the square root of factor? In temp is going to be a square root of factor. Like if temp into temp equal to like factor, it means that it is divisible. So in that case we can simply do dp of uh yeah, dp of I like free of I is going to be a free of I plus equal to temp of we can say uh, dp of temp. We can also define dp here. Yeah, dp size will be of n comma 0. So I think, yeah, that's it. And now again the temp is going to be a square root of temp. I think, let's see if it is working now. Because I think square root is also log n. Mhm. So let's see what is the value of temp. Temp is like if temp equal to 1, then we can say we can break this thing. So it is going to be a 1e5 plus 1, I think. Yeah, getting 6 answer instead of 7. Yeah, in case of temp equal to 1, we are getting yeah, let me print this free array. Authority comma free 0. I think it is. I think this is not way to calculate this thing because uh, tan is divisible by we can say, yeah, tan is divisible by 2. So let's ask ChatGPT, can we do this thing in optimized way? Can we do this thing in optimized way better than big of and scare? So I think it is for each possible divisor D, count how many numbers and multiples of D. So I think we can do something like this. We can say like a temp of I equal to 1, and we have something like a vector int and temp of n like 1 if 5 plus 1 comma 0, and we are going to make it temp of v of I comma 1 plus equal to 1, Like we can do it for 1 e5. Yeah, multiple equal to d plus di is say. One, two, three, or one. So d is equal to 1. Condition of d plus equal to temp of multiple. Count of d तो प्लस हो ही रहा है रे. I think it will look something. again syntax error. क्या ही हो रहा है? dpf I comma 0. It is v. So we have to do -1 for everyone. Because we can exclude itself. Think. So now I think it should work. So why it is not showing me? Uh, let's comment this thing, and also one more thing. This thing, and now let's run this code. Let's try to submit this thing. So I think it should now work. Again getting TLE. The hell is this? Not getting TLE here, but so I can say I can simply make int max val equal to 0, and for auto it comma v max val equal to max val comma max val comma v of I comma 0. So I can write max val everywhere. Max val max val max val. So why I am declaring this again and again? Temp, then count. Can I reuse this thing? No. I think let's run now. Uh, IT. So let's try to submit this again if it is working or not. So two test cases are failing. So if we can remove this thing, uh, and use here as. So how can we optimize this? So I think we can remove this loop, but again it is giving TLD for this thing. It's already 3:31 a.m. but but we can do further to optimize this thing. Yeah, I think we get TLE due to this thing. Like if this can be arranged from 1 to like value, all values are 2 2. So if the all the values are 2 2, then I think this must. Now I remove this extra thing also. We have now discount free, and like budget can be quite high. So instead of doing something like this every time, so we can optimize this thing like by taking if it is all possible. So like int max, like total 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 price is going to be total price is going to be p of I comma 1 t of I comma 0 into t of I comma 1. I must say, yeah, this is the total price. uh, if budget is greater than total budget is greater than total price, then what we can do, we can simply greater than equal to total price, budget minus equal to total price, and we can do something like uh, answer plus equal to plus equal to 2 into t of I comma, we can say 1, something like this. Else how much we can gain from this, like it is less, then we have to do something like total budget divide by total int gain is going to be a total price divide by budget, int gain equal to a total price divided by budget, and yeah, to, sorry, budget divide by t of I comma 0, and answer equal to answer plus e- answer plus equal to 2 into gain answer budget equal to budget modulo t of I comma 0, I must say. Let's see if it is work if it works or not. And similarly we do same thing for below thing also. Oh yeah, let's try to submit this thing now. Now we are getting wrong answer. If budget is total price is going to be t of I comma 0 into t of I comma 1. If budget is greater than equal to total price, then budget minus equal to total price and answer plus equal to 2 into total price. uh, we can say while budget is greater than equal to T of I. Well, there is no problem with LL. Let's command this thing. If it is giving, now it is working fine. So I think if budget is greater than equal to T of I comma 0. अगर टी ऑफ आई की वैल्यू 1 होगी तो 1 ही ऐड होगा, 2 होगी तो 2 होगा. Yeah. So finally it got accepted. So yeah, so let's see what I have done in this problem. So yeah, so the problem is like almost similar to the previous one. So in this what we have given like 2D, firstly we have given a 2D integer array of items where items of I is we have value like a factor of I and a price of I represent the ith item. And you are also given a like we have a given a some budget, and we have to buy like as much as items we can buy with that budget. So there are some condition like if like each purchase copy of item I can give you at most one free copy of another item J. Like if we purchase something like a item I, it give us a item J as a free where the factor of I divides factor of J, and I and J must be like the I and J is not equals. So yeah, or like another condition is that like for each pair IJ you can receive a free copy of item J from purchase of item at most one. So by this they mean like so if we have something like 2 4 6 8 9, so I am simply defining here the factor value only, not price also. So you can see like the 2 can divide 4 completely, and 6 completely, and 8 completely. So we can make some pair like 2 comma 4, one pair, then another pair be 2 comma 6, and another pair with 2 comma 8. So if we make something like this pair, then we get one free in this case also, this case also, this case also, because all these three are different pairs. So yeah, that's they are saying. And after that they are saying that the same item J can be received multiple time, like you can say if we have like use something like 2 comma 4, like now 4 comma 6, 4 comma 6 can also be can be a different pair also. So yeah, so let's copy paste the code here and see what I have done. I think this is the code. Does it get downloaded or not? So I think yeah. So like in the previous problem we are simply calculating the like for doing loop, and then we are calculating like if that I or J can be a divisible, like if I how many pair there can be formed, like so that the factor of I divides completely factor of J. So instead of doing that thing, so as the like a factor value can be up to 10 raised to power 5, so I am using something like we can say the same kind of approach we use in prime numbers while finding the prime numbers. So firstly I am finding the like getting the I am making two variable like min cost to get the minimum, like if like I am not able to find the pair, like if there is no pair exist, or I have exhausted all the pair, then it is always better to take the minimum cost items. So for that I am making this minimum cost item and the index of that item, and also updating the count of v of I comma 0, like a factor value, how many times I have seen that factor value. And previously I am calculating the maximum factor value of that, in a like all the items. So after that I am iterating from d equal to 1 to d equal to max value, that is a factor value. And I am marking all the I am marking all the multiple of that to be a, because I need how many items I can if we have something like this, how how many j this I can completely divide. So yeah, I am calculating that thing here. So is the the time complexity of this is going to be so what are the time complexity like, because it's not this firstly we are calculating for n into 1, so it is around, we can say that n log n time complexity for this. So yeah, then I am checking if the budget is less than equal to mean cost, then it mean it is not possible to buy one of the items. So yeah, and after that I am declaring answer as 0 and I am iterating the loop. And I am checking free of I is equal to now the free, in the free we have you can see we have including itself also. So we have to for that reason I am subtracting the one and store that value in a free of I. And after that I am making a t vector, and I am iterating the free array, we can say that free array. And I am adding the value like a price value, and the free how many pair it can make, free of I value main, how many pair it can make, so that we get the free count one. So after that I am sorting the array. And so yeah, then again it's a simple loop, I am iterating from this t array, and checking if the like if the cost to buy that item is greater than 2 of the min cost. Like so if we are getting buying one item, we are getting free item, one free item, yeah. But if the cost of that is greater than twice the minimum cost, then what is the benefit of that? So it is always so it is better to take this thing, we can take two minimum cost items instead of taking a one cost item greater than that twice of item with one free item. So yeah, then I am checking can we buy all the items of that kind, all the items with all the pairs. So if it is possible, then budget is going to be a minus a overall price items we can buy, and then answer is going to be 2 into the number of pairs into twice, because for every pair we are getting one item as free. So then if it is not feasible to take the whole, then we can take some part of that. So gain is going to we can only do something like budget minus budget divided by let's say if budget is budget is 100 and something like a value is like a 10. So we can say that 10 cross 10, we can only get 10 items. So yeah, so answer will be 2 into 10, because we are getting one free item as well. So and budget is going to be budget modulo t of I comma 0, yeah. And after last I am checking if there is some budget left, then I am going to buy all the mean cost items. So it's going to be budget divided by mean cost. So after that I am returning the answer. So yeah, so that's it for the today.